Hello guys, in this video I would like to explain about two sample Kalmogorov Smirnov test in Python. Before implementing this test in Python, I would like to give some brief information about this test, in which situation we can use this test, and how we can interpret the output of this test. You cannot interpret the result of this test if you don't understand for what purpose we are using this test, what is the null hypothesis in this test. So you need to know these things. It's very important. So we will try to give some basic information. This test was developed by these two mathematicians. As the first one, the one sample test we have discussed in the previous video. If you want to know about the one sample Kalmogorov Smirnov test, the link to that video is given in the description of this video. And two sample, in which situation we can use this test? When you have two data sets, normally we use this in the evaluation of some model scenarios or experimental data. If suppose you have climate data, you have hydrological data, or you have some other data, from different models, from different scenarios, or from different experiment, and you want to compare those experimental data with the observed data. You have recorded data, like I will take an example of the climate data. If suppose you want to test the climate data from different models for the New York City or for Berlin, you have these climate data from different models, and you have observed data for that particular station in New York or the Berlin or Moscow or whatever, Delhi. So you need to compare, that you want to choose the best model among them. So one way is to compare in this way. Just compare or test each data from the models with the observed data and see which data is closely related to the observed data, which data closely replicate the observed data. So you can compare or you can test different data sets and those model data sets with the observed data, and then look at the p-value. The highest the p-value mean that the experimental data or the model data closely approximated or closely follow the observed data for that particular station. Similarly, you can do in hydrology. Similarly, you can do in economics, finance, econometrics, and everywhere where you want to do data analysis. So the one sample Kalmogorov Smirnov test was only to test whether a particular data set belongs to a particular distribution or a specific distribution or not. In this case, in the two sample case, you can compare two data sets, whether they belong to the same population or they come from the same population or not. So if you want to test this test at 5% level of significance, in that case, if your p-value is less than 0.05 equal to or less, then you reject the null hypothesis and conclude that the two data sets do not belong to the same population, do not belong to the same distribution. So the data are different. And if your p-value is higher than 0.05, then this means that the two data sets belong to the same population or the same probability distribution. Or you can say simply, if you want to illustrate the result to non-statistician, then you can say the two data sets are similar. Okay, a statistician know that what is mean by similar, because there is a background, the Kalmogorov-Smirnov test. So this was something, the background, and now I would like to show you how you can see this material in the Google, and just Google it, and Kalmogorov-Smirnov test to sample detail. Just you can Google it, and you can see a lot of details and on Wikipedia, and you can see these are the two statisticians who developed this. A mathematician, you can say, the large, and Andrei Kalmogorov and Nikolai Smirnov. So you can see this is the single, I think. This is not one, this is one sample, remember. Just go to the two. Yeah, this is the two sample test. So you can see illustration of this two sample Kalmogorov Smirnov test statistic. Red and blue lines each correspond to the empirical distribution function. So this is one sample, the red color represents one sample and the blue color represents another sample. So, and the black arrow is the two sample case statistic. Remember that the K is some sample statistic you calculate. You just take the maximum value of the difference between these two. So where is the maximum difference? Like this is your test statistic. You can go back and you can see how this statistic work. So the maximum value, so this is obvious. If the difference is larger, this means that the statistic value is high and the p-value should be lower, and then you reject the null hypothesis that the two data sets do not belong to the same population because the difference is high. This is simple if you want to explain this in simple word. And if the difference is lower, this means that the two data sets belong to the same population or they are similar. And remember, this is empirical CDF, both for each data set. If you want to go back and you want to see the test statistic, you will see the same interpretation. Yeah, you can see that this test statistic is the sample size for, and the maximum value of this, the cumulative distribution function of the first data and the cumulative distribution of the second data. And this is the absolute value. So maximum value from these data from, from the difference. So this D and M as this black point, this black difference as D and M for you. So you can interpret, you can see different details. And if you want to know more and want to know some detail, you can write in the comments. I will try to provide the material, or you can say guidance. So this is something basic and about the statistic and in which situation and why we use Kalmogorov Smirnov test. You can see some detail here. Yes, two sample Kalmogorov Smirnov test is used to test whether two samples come from the same distribution. So as I already explained, so this is like this come from the same population or same distribution or not. So now let's go to Python and how we can do this. Okay, so this is now two sample KS test in Python, the small code, and I will explain each of these line and function that how you can utilize this with your own data. Okay, just generate these two data sets, generate two samples because this is two samples. So I explained this in my previous video. We are generating sample one, which is np numpy dot random dot normal, and location is 0, mean value is 0, and scale is 1, and standard deviation is 1. And just put this is 5, let's make it 1. So the same, and sample size in each data set is 1000 values. Just run this, but this will not work perhaps because np has not defined. So just you can write here import numpy numpy as np. Now this will work. So now we can do this run it again. So this working sample one, you can write here sample one and you will see the values. Yeah, these are the values. Just run the second one and you will see sample 2. Work smartly, not hardly, and just click on the upper arrow key 2 times. You will see sample 1. Just remove 1 and 2. Now sample 2. This is now sample 2 values. So you have two samples. So the required data you have now already, and you can use perform the case test. And this D will store the test statistic from this function, and the p-value will store the p-value from this function state dot case underscore two sample. That's for two samples. So just get wrote underscore 2 SAMP. So you can use this function, and in these are the arguments, sample1, sample2. Just run it. Okay, yeah, so because it's not working, because I need to import another library. This one I mentioned this, you can write here. You can just, oh, this will work now. So now you can run this. It's working fine. Now you can print the test statistic by using this command, and then the p-value by another command. So that statistic is 0.46, which is low, so you should have a higher p-value. Remember the difference between these two. So if the difference is high, that statistic is the maximum value, maximum absolute value of the difference between two CDF, cumulative distribution function. So if this difference is high, the p-value should be lower, and we reject the null hypothesis that the two data sets do not belong to the same population. But if this difference is lower, this means that the cumulative distribution function of two data sets is close to each other, and we should have a higher p-value, remember. Now just extract this p-value. Yeah, of course it is high, 0.24. So this means that we accept null hypothesis and conclude that the two data sets belong to the same distribution, the same population. And if you want to talk to the other pupil, non-statistician, you can say the two data sets are similar. Okay, now let's do some changes. Just make this 5 in the second data set. The first data set has this parameter, in the second data set the standard deviation is 5. Just run the second one. The first one is already we have sample 1. Sample 2 is now different, and you will see the values are different. You can write sample 2. Yeah, you have now higher values, 8, 8, minus 8, minus 9, and yeah, 3, 4, yeah. And now again run this, you'll see. Okay, now extract the test statistic and then the p-value. Yo, the test statistic a bit higher, it's not that low now. And yo, the p-value is very small, 4.649 e raised to the power minus 5. It's very low. So this means that we have insufficient information to accept the null hypothesis and conclude that the two data sets do not belong to the same distribution. And it is quite obvious because this data set have different parameters. Location parameter is 0 and the standard deviation is 1. In this case, the location is 0, but the standard deviation is 5, it's far higher than 1. So of course, does not belong to the same population. That's quite obvious. You can experiment this with different things, like you can use 10, and then you can run this. Again, two sample you have to run again the same test. And now you can extract this statistic here. Again, this does not belong to the same population. Of course, quite different. Here you can see. Okay, now you can change the parameters. You can do like this is 1, you can do this 50. Suppose the mean value for the first data set is 50, second is 0. Just run this. Now I'm changing the location parameter. Run this test statistics, and yeah, you can see higher value, the very high value of test statistics. So we must have very small value for p-value. Yeah, that's 0. Of course, there is nothing at 0. This is the least value of the probability, p-value p. So of course, because this is 50 and this is 0, it's quite different. You can do it maybe 5, then you can see whether it's, in this case, the test statistic value should be a little smaller, but still let's see how we can. Yeah, still it is high, and it should have a small p-value. Yes, we have small p-value, very small. So this is all about that, how you can test whether the two data sets belong to the same population or not. So this is Kalmogorov Smirnov test for two sample data sets. But now I have another data set. Of course, when you have data set in the CSV file, you can import that from CSV file. We have already done this, so you can go and you can see the playlist of this channel, which is titled Data Analysis with Python. So we have started from very basic, installing Python, Spider, Anaconda, and then we have we have done some videos that generating random sample, random numbers, and then so step by step, if you want, you can go back and you can see the videos. I recommend to watch those videos if you want to know, because now we are little, we are still beginner, but yes, we are doing data analysis now. And okay, so I have another data set. This one is just to create this data set 1, 2, 4, 8, 9, 12, 3, 4, 1, 5, 7. Generate this data, and then I just multiply this data with the 5. Y represent a data 5 times of x. Can just write x here. This is the data set, and now just multiply by 5. You will have another data set that is equal to 5 times simply that 1, that 5, 2, 10, 4, 20, 7, 35, multiple of 5. So now we have two data set. Similarly, as we have done here, just apply the case test to x and y. Now extract the p-values. The statistic is quite higher, by the way, 0.72, 73, by the way. P-value should be smaller, quite obvious. 0.004. So we reject the null hypothesis and conclude that both data sets do not belong to the same population. They are different. The two data sets are different. If you want to explain this to the common people, not statisticians, say the two data sets are not the same. Okay. And let's do this with the 2 times, maybe then they are close. So maybe we can say that the two data sets are similar. Just try this and you can have multiple experiment. We will see test statistic is, yeah, still it is high. Let's see the p-value. Wow, the p-value is like this. So this means that the two data set in that, because it's not quite different. It is different, but it's not too much different. This is 1, so there y have 2, this is 2, the other have 4. So you can do different experiment. This was just for illustration of this test. Of course, you will have your own data and you will want to test whether the two data sets belong to the same distribution or not. So you can, if you have more data set, of course, you can compare pairwise with the observed data, and then you can compare the p-values for each data set, which data set has the highest p-value, and then you can say this data is much closer to the observed data in comparison to the other competing data sets. So this is all about Kalmogorov Smirnov test, two sample test. And what we have learned in today's video, we have learned that what is Kalmogorov Smirnov test, why we use this test, and which situation we can use this test, in which areas we can use this test, and then finally how we can implement this test in Python for data analysis. So if you have any question, please write in the comments and I will try to answer it as soon as possible. Thank you very much and see you in the next video. Ciao.